All right. Hello, everybody. Welcome back. We now have two fantastic sessions for you to choose from. Over on the session page, starting in 10 minutes at 16 CST, we have a focus session on the hugely topical subject of the 9 killer questions you need to ask about conversational AI. So we have Tim Bartz, pre-sale consultant at Artificial Solutions, who will explain the key concepts you need to consider and the vital questions you need to ask of vendors pushing their shiny wares. He'll decode the technical jargon and tell you what really matters and what's just marketing hype. And now, here on the main stage, we have another tech talk that is on the subject of object detection kit, identifying urban issues in real time. To tell us more, I'm delighted to welcome Maarten Sukel at the City of Amsterdam. So the City of Amsterdam AI team works on researching and developing new AI technology, working alongside academic partners to build and deploy ethical and sustainable AI solutions for urban environments. Welcome, Maarten.
Thank you, Jeremy.
Yeah. All yours.
So I will share some images since we were talking about computer vision. So this should be fine. So yeah, my name is Maarten Sukel, and I'm here to talk about how we in Amsterdam we're detecting urban issues using object detection, so computer vision AI. So the problem we're trying to solve is when somebody's walking through the streets of our city, noticing garbage on the street or noise on the canals, broken bicycles, of course, in Amsterdam. Right now, people will hopefully know that they can send a message to the local government by going to our website or going to one of our phone numbers. And this will work pretty well. With like somebody will tell there's garbage on the street and can this please be removed. If they do this in Dutch, the machine learning algorithms we use to route these service requests, since we're using machine learning for that, they work really good because there's lots of examples of this happening and a lot of people are speaking Dutch. But what if somebody is, for example, an expert in our city and will do so in English? Less reports are being made in English, so it will work less well. The system. It will still probably go to the right department, but it might have some delay because somebody needs to reroute it to like the correct type of garbage. And what if you're really like clumsy? You're not that good at typing. Your hands are too big for your phone. You don't have a phone. You don't even know that you have to find us. These are all ways where a system that's already being used, that's being optimized with AI, might be creating a bigger bias in the city. So that some neighborhoods will be less well maintained than others because more people know how to contact us. So, for example, you would have a neighborhood where a lot of service requests are being made, a lot of maintenance is being done. And if you have a neighborhood where there's no service requests, there might be a lot more waste or less well-maintained areas in that area of the city. So the warning I want to give is like technology can give opportunities for optimizing government services or, of course, services for any business. But it can also increase biases or societal differences that are already maybe existent in the current world. So in Amsterdam, we are investing in creating what we call Amsterdam intelligence. So AI that works for the people of the city. I mean, not just Amsterdam, all people all over the world, but we're focusing on our own city. What this basically means is you can read more about this in a magazine we wrote. It's called Magazine Amsterdam Intelligence, both available in English and Dutch. You can see this nice introduction text from our deputy mayor, Tuya Miliani, where she says, well, we want to invest in artificial intelligence. We're also aware of the risk, but really want to focus on making Amsterdam a free, just, and sustainable city, and also be inclusive, creative, and do this together with others. So we have a lot of universities as partners. We want to work together with the private sector and other public authorities to maintain this goal. So in that context, I want to go to the object detection kit and why we made it. So the advancements in computer vision have been going really rapidly. It's now possible to have a computer system analyze images and tell what you see. So you can see it's water, a river, a building. It's still doubting like if it's water or a river, but it's pretty good. So you can see like the level of detail this panoptic segmentation, as it's called, is doing And this is a model that's not trained on this footage, so it's really just taken off the shelf and used to demonstrate how good these already work. You can see like in a busy environment, these models can see a lot of things we can understand as well, like where is a truck, where is a bike. Yet we were thinking, how can we use this technology to fix the other problem of some neighborhoods being maintained well and some not, and at the same time maybe do that a bit more efficient. So what we did, we made a system called the Object Detection Kit. It's completely open source, freely available. We made it together with some universities, some academic partners, and several other cities in the Netherlands. Basically what it does, we're fitting smartphones to garbage trucks. These are scanning the environment, and when something is noticed, we will use this information to clean the streets more efficiently. And more information about this can also be found on the website objectdetectionkit.ai, odk.ai. So basically what the system does is it's turning a camera into a sensor. So it will detect like these little poles we have. In Dutch, we call them Amsterdammertje, which is like the name for this typical Amsterdam brand of poles we have. But it will also detect garbage bags or cardboard on the road. At the same time, it will filter out faces, license plates, so we don't need to store that information. So we will know like what type of garbage is anywhere in the city. We're making these systems so that they're only registering basically the things we want to see. So you can see this camera as becoming a sensor that's capable of seeing there's a construction site here, but it's not noticing that there's people walking there and who's walking there. And the goals of these projects are of course, multiple goals, but most importantly is we want to collect garbage more efficiently and with more equality throughout the city. So we want to remove this imbalance we might have and discover if there is this imbalance and then fight against it. And at the same time, of course, we want to be more sustainable. So that's also something that's possible, because we can see a lot of detail here. We can see there's cardboard or garbage bags. Also, there's furniture that can be sent to a thrift shop, or a mattress, which becomes worth money if you can recycle it instead of having to remove it, burn it when it's become wet from the rain we have in the lovely weather here in this time of the year. As you can see, it will also work for those different types of objects. So you can see the furniture, wood, that might be able to recycle that or collect separately. So it can detect all these things. And we are constantly improving this together with what's working, what do we want to know of the city, and also add that to the detection of the system. And as I said, it's using smartphones. The reason for this is not because we don't want to use big expensive cameras, but we think it's important that this system is really frequently scanning the city, and is also very accessible for citizens, so they can scan their own neighborhoods, for example. So the system runs on almost any smartphones. And yeah, basically you can put it on your dashboard, put it on your bike, put it on your head, whatever. We don't care, but this will help us to see where we can fix problems in the city. And this makes this really accessible and cheap technology to deploy. So basically, this is one of the outputs we're having in the city of Amsterdam, where we're doing these scans with our garbage department. They're checking for areas where there is where there's objects next to the containers that need to be cleaned, and this will allow us to work more efficiently by first cleaning out anything that's blocking the way, and then later we will send in the big trucks to actually pick up the containers. And of course, the whole system is privacy by design. This is when you're using cameras in the public environment, we don't want to track anybody in Amsterdam. So this is why we immediately filter out faces and license plates in the data we store. And sometimes we don't even save the data. So we're just, as I said, we're just processing this on the device to see what's there. But we need, of course, with machine learning, we need some examples to start training our model and make it better. But eventually, we won't need to store any images at all. And then, of course, there we can make like decision to only do like license plates, faces, or entire cars for people. And we discovered that AI doesn't like so if you blur something, so we decide to just make that a completely black part of the screen. So this is eventually how the system is going to be monitoring. It's just seeing the issues and removing all other information because we just don't need it. So the software component's a bit more technical, but basically what it does, we can have an n number of smartphones that's streaming to our servers right now, and there it's processed by also a flexible number of frame analyzers, GPUs. All this code is open source available, so feel free to take a look what our developers are doing. And of course, we will also be sharing the dashboards and everything, so hopefully other cities will also be using this. So I said we have work more efficient. If you know exactly where everything is, the ultimate dream is to have an Uber-like system where we can, for example, if you know where all your trash is and you know where all your garbage trucks are, you can optimize this also with AI, just like you have Uber optimizing their drivers picking up passengers. It's basically combining the demand and of the market with what has to be done with your workforce, basically, and doing that really efficient. So that's the ultimate dream, is to be able to clean cities like that, making it really well efficient, because if you're driving less kilometers, you're using less energy, so that's also more sustainable. And also making the maintenance more fair, as I mentioned before. We have a lot of bicycle symbols in Amsterdam. They're on the roads, and they're here to tell people this is where you bike. So for this, we processed 23 terabyte, I believe, of panoramic images, where we're basically finding a location of these. And the next step we want to do is, for every neighborhood, every borough, we will calculate how well, what's the amount of decay for these symbols. So apart from all the systems we already have to maintain this, make sure the traffic is safe for the bicyclists in Amsterdam, we want to see if there's like a difference in maintenance between neighborhoods, also because of the same imbalances that might be occurring in cities. And like I think a month ago, we launched the algorithm register. It's basically a website, a portal where people can come and look at all the different algorithms that we have in our city that we're using that influence your life. And we will be completely transparent about how they work, who made them, and what type of data is used, what biases might be in there. We will be adding more and more of these algorithms to it once we develop them. So yeah, this is like the small overview. We're doing the mapping the city with the computer vision. At the same time, for example, we're also using the same technology to see if there is advertisement on windows, so we can automatically text that for the whole city. We're using it to add detail to a 3D model, so this becomes for game engines. This can be used. So we're doing all sorts of things with computer vision to improve city life. For example, we're also doing things with the natural language processing side of AI. So, for example, the system I showed for routing the service requests for cities, that's also something we're developing now with multiple cities to have an open source standard for this type of system, also using the machine learning to be able to help people more quickly and more efficient. And at the same time, there's also like a sneak peek in another project we have. We're using AI to beat COVID. Well, maybe make it a bit more easy, make people aware of keeping their social distance by having a screen on markets where it shows if you're keeping enough distance or not, and else it will give you like a visual warning. And at the same time, we're predicting what type of measures are optimal to take in the city. So this is also something where AI comes into play. So with those last few, this small sneak peek, that's what I would remind you that we have some more information on the website that's on the screen. On my LinkedIn, I always share all the updates of the project we're working on. And if you're interested in what we do with AI and why we do things with AI, please Google the Amsterdam Intelligence magazine, and you will definitely find more information about that. So for that...
All right. Well, thanks, Maarten. So if you have questions for Maarten, please follow him into the networking lounge speaker room. I think he went directly there. So follow him if you have questions. The link is in the chat, so check it out in the hop-in chat. And Maarten can turn his camera and audio on, and you can type questions for him. So right now, we'll be back right after a short break and try to do some one-to-one networking with the networking tab if you haven't yet. And I want to see those tweets. Thank you a lot, guys.